Hello, everyone. On behalf of Indian National Trust for Art and Cultural Heritage INTACH and the INTACH Conservation Institutes, I extend a very warm welcome to our distinguished speaker, Albert Kieferle, and everyone who has joined us for today's talk in the Conservation Insights 2020 lecture series. I'm Dr. Padma Rohila, Director, ICI Delhi. Now to introduce our speaker, Albert Kieferle is a restorer at AeDis AG, Germany. After having completed school in different parts of Asia and Germany, he took an apprenticeship as a stone cutter, eventually drifting more towards stone conservation. In 1983, he took up studies of art history and European anthropology at the Eberhard Karls University in Tübingen, Germany. Since 1988, he has worked as a freelance restorer, and in 2002, he founded AeDis together with George Schmidt as a restorer and Peter Reiner as architect, focusing mainly on planning of restoration and practical restoration of high-quality historic buildings. The idea was to closely link planning and conservation. In the past, he has committed to conservation of many prominent buildings, such as the Castle of Heidelberg, numerous Gothic churches from the 13th century onwards in the southwest of Germany. The title of today's talk is Conservation of a Recent Conservation Based on Ethyl-silicate and Colloidal Silica. The minster of Salem-Abbey in southern Germany, built on various types of molasse sandstone, underwent a conservation based on a consolidation with ethyl-silicate and injections, edging repairs and slurries with a colloidal silica binding in 1977 to 2002. These works had originally not been planned during the restoration phase, so work was only done partially, meaning a minor set of conservation measures. In 2009, there was a chance to take a closer look at the facade of this minster, and it was found that there was no change since 1997. However, in 2014, while planning the previously omitted steps, this had changed. The gaps that had been closed 15 years earlier had reopened and new hairline cracks had appeared. So these new gaps were too narrow and hence were filled with silica-stone-glue with a better viscosity. So the talk today will be discussing this situation and the careful retreatment with ethyl silica in a situation such as this. Before I request Albert for the talk presentation, may I please request all of you to mute your microphones. Please type in your name, organization name, and email ID in the chat box, and also your questions. We'll be taking those right at the end of the talk. Thank you, Albert. Over to you now.
Okay, thank you very much for giving me this opportunity. We had a big discussion on retreatment of stone material based on previously treated with ethyl-silicate in my last little talk on the Lusthaus Ruine at Stuttgart. And so I thought I would present this over here and actually to go further into this discussion, because I think this is one of the questions, at least here in Germany, where ethyl-silicate was very extensively used, will be one of the major topics in the next couple of decades. The talk was originally planned for Göttingen in September 2020, but this meeting was cancelled, so it was not. It was published as text, and but it was not held actually. And when I prepared this talk now, a couple of views shifted somewhat. You know, it's always when you go into some a subject once more, you see somewhat different things. So actually, this reflects my beliefs at this point in time. The talk itself, I'll present a little case history, because this is very important in this thing, because it has a somewhat not very straightforward history. I'll have to introduce the stone material, The Swiss colleague will know it. It's not very easy to treat, and it has some very grave problems. So then as a section on the examinations we did will follow. I'll introduce the project we'd actually planned, and the treatment which was then given was differed somewhat from what we had actually intended to do. But let me just first give you a location of Salem-Abbey. It's in the quite to the south of Germany. Actually, you can see it in the map. It's almost center of Europe, as if you just omit Scandinavia and Russia from from Europe. But yeah, it's directly north of the Alps. Do you see my my mouse? This is actually the Alps you have coming here from Switzerland and Austria. Over here, this is the Black Forest, and down here is this little bluish patch is the Lake of Constance. If we zoom in further to the Salem-Abbey, you can see Baroque gardens, and this is the minster, which our concern will actually be. These are the buildings where the monks used to live, administration buildings, representation areas. These are more. These buildings up here are more for the farming, their barns, etc. So we'll actually be focus on the minster itself over here. It had a very turbulent history. Over here on the top, stating around 1650, is you can see a very only minor monastic buildings. The cloisters over here and some additional buildings over here. In 1687, there was a big fire which started somewhere around here and actually ruined all of these buildings. In the early 18th century, then these buildings were rebuilt. You can see in this painting over here, you can see the newly very large and very modern at those times buildings. The order which this building, this abbey belonged to, became quite important, and this abbey in the 18th century, and this abbey was at least was one of the main abbeys of this order. So that actually explains these very representative buildings. In 1803, during the French Revolution and the wars following it, the monastery was shut down, and fell into some neglect for quite some time. The right picture, this black and white picture on the right side, is the situation in around 1870, probably. It's not dated exactly. Actually, it's between 1780 and 1880, no repair, no maintenance was actually done. In 1885, finally, there was a big renovation which took place, and a whole lot of sandstone portions, especially the more slender parts of traceries, etc., were replaced in Rosha Sandstone, which is a molasse sandstone. soon afterwards, actually, I have reports from 1840s where they say from 1940, 1950, students who lived there. In the meantime, it's a school. Reported that there were parts falling off, the laminations at great scale already actually 60, 70 years after the renovation. This encouraged the further replacement of stones, which was the typical way of handling these things until the 80s or even 1990s. Sorry. Yep. Over here you see a mapping of the stone material. The yellowish material, the yellow marks show the medieval sandstone. The green patches, they show Baroque material, and the gray areas, the gray stones, they were all replaced in this campaign between 1895 and 1885 and 1890. Over here you can see yeah, okay, in 1997 scaffolds were put up actually for in order to repair the roofs, which were severely damaged at that time. But when the scaffolds were put up, these are the photos on the right side is actually what could be seen. So the laminations were very severe. The covers of the buttresses had loosened themselves, etc. And this is actually medieval material which rounds, but that doesn't make that much problem, or at least it doesn't endanger any people walking along. But you know, if these delaminations on the right bottom side drop off, it can be several kilograms of weight which come down. The mapping over here shows the delaminations by how severe they are. The yellow ones, that means they're less than 50% of the surface of a stone itself. The reddish means that there's more than 50% of the stone surface actually delaminated. So, and the stones, you know, they have something like several, half a square meter or so. So this actually means that this is really severe stuff, a severe problem. So it had to be faced. But the problem was actually at that point we couldn't. There was no budget for these for the conservation of it, for anything beyond the roof. So together with heritage authorities, etc., and all the owner, we managed to put up a budget for a small campaign conservation project, which just involves conservation. Actually, you know, there was no stone replacement, which was inevitable actually, and because actually, you know, these very large scale delaminations you see here, there's no, at least until now, actually, there's no way of really reattaching them in any way which we would regard as being sophisticated and enduring. Yeah. So these severely damaged the delaminations were actually taken off, and there was only some sort of an edge repair done at this point. But the stones which were regarded as stones which blocks which could be conservated for a long term would were there was a conservation done which invoked some filling of all the gaps and the laminations in it with colloidal silicate bound binding with quartz and some add-ons for improving the flowability of the material, and there was consolidation was done, and as you can see over here on the left side, there was a lot of edge repairs done. The over down here you can see a plan which shows what has been done in detail. Actually, the information I want to give you with this is there's actually no piece of stone from Rosha Sandstone which was not done when nothing was done, or when no consolidation was applied in any way. This was the technique at those days for filling gaps in the laminations. Hoses were stuck on top of the gaps, and the gaps were closed with on the surface with hot glue, and eventually the material for the filling was applied and reapplied. So that was the advantage of this technique was that there was always kind of a reservoir, and in these hoses where things could be refilled, and so it was given a long time to let it flow in. Another technique uses pressures and injections. Yeah. So in 2009, we had a chance of re-examining the things. Although this is a photo taken of a very strongly damaged area in 2009. These the colors had not really been very sophisticated or very lucky, but these the things were actually all closed. This examination was done in a cold and dry winter day. This was probably one of the reasons why this was the case. In 2013 or 14, I just added this 2013 out of memory. It could have been 2014 probably. We re-examined it on a warm and wet summer day. That gave us a completely different impression. There was these cracks had reopened, giving access to hair, forming new hairline cracks. These are okay. No. The width you see over here, this portion, this round piece over here is has a diameter of maybe 3.5 centimeters. So it's actually quite fine, but nevertheless, these gaps will lead to a strong large intrusion of humidity, of water, rain, etc. When they get wet. Let's take a little small look at Rosha Sandstone. It's actually quite a decent building stone from from physical points of view. It consists of coarse carbonates. The cementation is carbonate primarily. There's not too much mica in it, so this doesn't cause any problems. But you have glauconite in it, and this is a mineral which has a large hygric dilation, a large swelling when it once it gets wet. Over here you can see some values taken from literature. It's Kocher, Matthias Kocher, the PhD of Matthias Kocher, which I cite here. It has something like almost close to a millimeter per meter, and it's typical. Something you can see is, it's not the same on every direction. It's always somewhat more. The direction is also go down to the bedding. So these values are typically quite a bit higher than the other ones. The ones parallel to the bedding. So we examined the treated samples taken from the building, which had been treated in 1997. You can see over here the hygric dilation is strongly reduced in the treated zones. Over here in the untreated, unconsolidated zone, we have the values we know from literature. Over here at the right angle to the bedding, it's naturally higher. It's this behavior of not being the same in every direction. This is still there, but it's still quite reduced compared to the untreated zones. We also looked at the adhesive tensile strength in consolidated and unconsolidated probes samples. We got a somewhat unclear results over here. We had actually expected that the adhesive tensile strength in the consolidated zone should be higher than in the unconsolidated zones, but these were really naturally weathered blocks, so it can quite easily be that these measurements taken from the consolidated zone of the same block were quite a bit represent very strongly weathered but consolidated values. It's quite difficult to actually show ethyl-silicate reacts to silicon dioxide, so it's quite undistinguishable to quartz from a chemical side. So we just have to live with some kind of hypothesis over here without actually being able to, with a reasonable amount of effort, to really distinguish these things. Okay. The other thing is there's quite a difference between the tensile strength in when measured on dry samples compared to wet, and this means completely saturated samples. So they're really quite a bit lower than the ones which would take the measurements that were taken on dry. samples. There was another series of probes. This is the two columns to the left side, which were taken from traceries. So these were very slim pieces, and they something like 12 to 20 centimeters in measurement, and we'd actually expected to find some untreated things and consolidated material in the center of this part. But if we look at the measurements, we actually have to see that it looks like this was really completely consolidated down to the center of it, which means actually the penetration had from every side must have been something like 7 to 10 centimeters. So, but these parts had large gaps. The stone material was had a very loose appearance, and so these parts definitely had a very very large, very porous system with very large diameters, etc., letting the ethyl silicate really penetrate extremely deep. So these were not regarded as representative, but nevertheless they showed that the depth of penetration is was very high in these parts. Nevertheless, we found strong sanding on the surface of the stones. So we considered, we tested some reconsolidation with very little, applying very little ethyl silicate. Over here, this means actually, this has the amount of silicium dioxide which is put in, which may react inside the stone, would be around 5 grams from these 100 milliliters. Over here, with this with this was about 8 grams. This means that this leads to about 10% in weight. So this means 80 milliliters. It's approximately 1 kilogram per liter. So this would mean something like 8 grams. Over here, this is 300, but the 300, this would mean that 30% of the material apply will result in silicium dioxide. So this will be something like 7.5%, and this is the so-called elastified ethyl silicate, which is able to create some more elastic bindings between the particles, but it leads to the same amount of silicium dioxide, which is applied to the stone. So actually, it was very little, and it was actually only intended to really to to apply to the couple of millimeters which are on top, which was actually sanding. The probes were evaluated using drilling resistance, and this is the apparatus you can see over here. It's solidly back in it was developed in the 80s, and it gives us quite an impression of technology in those days. Actually, this case only has a sledge in it and a drilling machine. Over here we have a little, this is the drilling machine is pushed towards the stone by a weight. And over here there's just a paper recorder, quite simple mechanical solution, but nevertheless it does actually do its job. There's no computers or anything like that involved in this 80s technology. Over here you can see the results, which were then which actually are taken from these measurements. And over here you can see the stone before applying a reconsolidation, and down here this is the result after consolidation. The danger we had seen, or we were afraid of, was that there would be a hump which would be created over here, leading to to a zone which was too excessively consolidated. Over here, this is the situation after consolidation. This hump did not come, but the other side is there was not too much result in actually in consolidating this top layer. So we came to the result that consolidation was not necessary. The measurements were taken by Ettel and Schuh from Munich. So our original plan was to raise the depth of penetration of ethyl-silicate in order to move it back from the surface which is affected by rain, etc., by humidity from the atmosphere, from weathering. So, and we had planned to use the gaps themselves for this for moving it in, for getting it deeper. Over here you can see the traceries which are part of the stone block in the back. So there's these tracery things have a very large surface with very little volume. So actually we thought if we could we would reapply it to these gaps, we would actually move in the treated zone quite a bit deeper, just in order to move it to get it away from the weathering. So there would be less tension between the treated and untreated zones. We had planned to wait for ethyl-silicate to react fully, and then fill the gaps with the colloidal silica, as had been done 20 years before, and is still actually state of the art at this moment. A further consolidation of the surface treatment was not intended. We had decided to accept this minor sanding on the surface, and just in order not to, in some maybe problematic zones, or which, these sandstones, they will vary from one block to the other to a great extent. So we didn't want to take the risk of doing so. But these materials with bindings of colloidal silicate, they do need a consolidation with ethyl-silicate in order to be strong enough to, we have winters where we have to see that in some water saturated situation, these we will get frost in it, etc. So we do need this this consolidation of these materials which apply to the surface in order to have them to make them durable. So these were the first approaches, first samples which we have done. Over here you can see the packers glued on top of the gaps, and here the filling is done with some injections. The results were not satisfying because the gaps were narrowed down by the previous filling, which prevented the material from actually flowing into the gaps. They would just spread a couple of millimeters to each side, or maybe some places a centimeter, but it would not lead to a decent filling. After quite some discussions, we came to try a material which was originally developed in order to glue Dutchman's repairs. That is little stone pieces which are used as repair, especially on cornices, etc., where you have a large amount of water rainfall coming on it. The main components of this material are calcium hydroxide, quartz, and ethyl-silicates, and some stabilization additives. And we knew it would flow very well, but we were actually afraid of applying it because this calcium hydroxide may lead to gypsum, which is the main cause of for delaminations, because on the molasse sandstone it was observed that the surfaces were actually there was a layer which contained a whole lot of gypsum in a depth of 1.5 to 5 millimeters, and this actually led to enlargement of the surface area, which actually made the laminations pop off the sandstone, the stone core. And so we actually hesitated to add some calcium hydroxide, but in the end it was actually the only thing we could use which would not be any epoxy resin or anything like that, because these materials, they just inevitably lead to isolation or to a blocking of transport of to the transport of humidity, and this typically leads to very severe damages on the humid side of these layers. And actually, with delaminations, you always have a layer which is parallel to the weathered surface. So either you get the front portion, the outside portion on in areas which are more which have more problems with rain, or you have it with on the rear side, on the inner side, if you have a area where you have more humidity from the ground, it won't be able to dry off. So actually these zones behind it will typically be extremely wet, and there will be an extreme amount of salts, very strong contamination with salts on the rear side in these areas. So we were actually not very fond of at first of applying this material, but so actually, these plastic, these epoxy or acrylic materials or anything like that, they were completely. It was actually completely impossible to use these, and so we came back to this what was developed as this silicate-stone-glue. And we applied it on some samples, and we saw actually there was this is the gap which was filled, and with the bare eye we could not recognize anything which looked like a gap behind it. So with this material there could the application could be applied wet in wet after consolidation. So the first step was to apply consolidation, the ethyl-silicate for consolidation, and then the silicate-stone-glue was applied to these gaps. Actually, this in the same way that the colloidal silicate material was applied. And naturally, the flowability was improved by this ethyl-silicate, which was already in the stone, so it would not, just be suck away into the surrounding stone area, and it led to a very decent filling. The material, the amount of stone silicate glue which was applied in the end was rather small. So we thought it was not very much of a problem when we have a handful of grams per square meter of facade. And the other idea we had was, this delaminations are over here, at least for the with the Rosha Sandstone, depend on gypsum which is created in the back of the surface, and eventually transported towards the surface very slowly over decades or more, maybe even centuries. But and then you have a zone where there's a drying, and the drying actually leads to a situation where the transportation of gypsum to the surface will not take place. So there's no washing, or at least the production of gypsum inside the stone is faster than it's been than the washing. This was definitely true in the times till the 1980s. But meanwhile, we have a strong pollution with sulfur dioxide has been strongly reduced. So we have only a fraction of the sulfur dioxide emissions which used to be there back in the 80s. And so we think the washing will be a stronger effect. Then hopefully the washing will be a stronger effect than the creation of the gypsum. But actually, we don't know, and we will have to look at to see. I haven't come across too many too many buildings where we had the sandstone, and we clearly had newly where we had delaminations which were created, or which came in very recent times, but this is actually completely unproven. So I think but actually we hope that this gypsum will not be as much of a problem in future as it is today. And I think there's good reason to hope for this hope. So these over here, you see the results of this treatment. Naturally, which I didn't show the replacement of stone, which was just along this cornice over here, was had happened to quite some extent. Over here, you can see these cylinder traceries which had been replaced. The traceries over here were completely treated as in conservation techniques. The socket zone down here was to quite an extent replaced, and you can see some still not replaced stones over here on this photo. This is these are treated surfaces treated by conservation after when it was finished in 2017. Okay, that's actually it. And this is a little winter impression from Salem-Abbey, and just seasonal.
Thank you, Albert. I don't see any questions. Please type in your questions in case you have any. Just one question. What do you think from my side? What, according to you, led to these cracks? Any specific reason? Was it the stone?
We think that there was some, once water penetrates into the stone, there's naturally some kind of a swelling, some kind of taking place behind this zone, which is consolidated. But this doesn't happen to this extent. So this probably is why these cracks had reappeared, and this was actually the idea of pushing back the horizon of the penetration depth of ethyl-silicate.
Any questions? No questions. I think that's very nice in a way. Absolutely no questions.
I thought this would after our last discussion, I thought this would be highly controversial.
I know, we were so. Anyway, we do have one.
Adva, I have a question.
Yes, I read that. Why silica? Yeah, I know, I read that. I just saw it. Why silica? Albert, that's the question.
Can I ask the question?
Yeah, please.
Sorry, I thank you so much. This is such an interesting talk. First of all, it's so great that you can go back and look at treatment that you've done in the past. this is a fantastic opportunity to understand how things
Yes.
work over time, and it's so rare. So it's great to hear this. I wanted to ask you, I couldn't understand exactly. You had some comments at one point on the colloidal silica, on the behavior of the colloidal silica, and you mentioned that it needed to be reconsolidated. So I assume this is the colloidal silica applied in 1997. Is this correct?
We did have to do apply some colloidal silicate in 2016, 17 too, because naturally we had to close the gaps on the surface, and we didn't want the white material to show on the surface, etc. So, and these areas had to be consolidated anyway, just in order to stabilize the colloidal silicate.
Okay, and then the other question was about the recent use of the silica-stone-glue. I understand instead of doing your closing just with colloidal silica, is this a replacement, a material that you use instead than the colloidal silica? Did I understand correctly?
For filling of gaps, yes.
Yes,
because
and can I?
It has the ability to flow and to penetrate deeply into the gaps, where the colloidal silica has much more problems. You know, actually, the advantage of using this silica-stone glue is that it has some adhesive tensile strength, about approximately 1 Newton per square millimeter, which is approximately in the range of sandstones.
Yeah.
And actually, the colloidal silicate has zero adhesive tensile strength.
Mm-hmm. So do you foresee the silica-stone glue to behave better over time in terms of the expansion that you expect the stone to still be doing? Is that also one reason why you choose the silica-stone glue over colloidal silica?
Actually, the main reason we chose it was the lack of alternatives.
Okay.
Shouldn't be underestimated.
Yeah, because basically you did see when you went back to look at the treatment, the main issues were the fissures, the cracks that were open up again. Is that correct?
Yes.
And so, yeah, it was actually, the idea was we had to close them, and in order not to have the humidity or to rain, etc., to penetrate into the cracks, and the main thing which led to the use of this silica-stone glue was actually that it would penetrate into it, but it was not. We thought it was a good idea to have a material with some adhesive tensile strength, in the hope, because actually when you use colloidal silicate, it's just a filling which lies inside the gap, but there's no real adhesion to the sides of the gap. So this was actually something we did regard as being an improvement. We hope it will not lead to new gaps, which will occur eventually. 2 layers of half a millimeter besides the old one. We can't actually say by now what will happen. But actually, the main effect is having the gap closed and actually having pushed the zone between consolidated and non-consolidated towards to the back.
Okay.
Great. Thank you.
Thank you. The next question is from Barbara. How many of the previously treated areas needed to be retreated? And could these areas be specified? That is, there was a weathering exposure or something specific in those areas that they had to be retreated. Oh,
All of these zones, actually, we have at this point we have had a chance to retreat this one facade. We weren't yet able to touch the other facades. There will be three more to come. So, and I hope we will be able to be involved. We will manage to be involved in these projects too. So but this is the facade you see over here this is a west exposure. So this is naturally the most severely exposed area, and it's a traceries which are actually mainly in damaged, and with these slender parts in here, with these very fine portions over here, and it's naturally the areas which are just below the zones where you have direct rain and snow, etc. Yeah.
So the remaining facades are also showing the problem. That's what you're saying. The other sides are also showing the problems. The cracks are there in the other facade, the other parts of the building as well.
We have a sort of a very curious and very with a lot of decisions made out of some situations and some monetary limitations, etc.
Okay.
For instance, this area was treated before this area had been, but this area this was probably treated in 2013, 2014, or 2014, 2015. This was then finally treated in 2015, 2016, and 17. Mm-hmm. But these areas were not treated in around 2000. Okay. But this area was.
Okay.
So it's not.
Thank you.
There was just, people regarded that there was just, these areas with the doors below, etc. They were endangering people more. And these zones over here, they were just closed by adding fences.
Thank you. The next question is, do you think liquid silica should not be used on conserving marbles? So is there any side effect of using liquid silica on marble monuments?
I have very little experience, or actually no experiences doing conservation on marbles.
Okay.
But typically using silica would there's a necessity for having silica inside the material itself in order to have something for the material to bond to. So I think there's hardly an effect. Over here we have some ethyl-silicate, which has the ability for bonding to lime, which has been modified in order to a group has been added where which gives it a bonding to lime. But it's mainly used in conservation of plaster, etc. But marble, no, not. I'm a sandstone person, which is actually only we only hardly have anything else but sandstone over here, which is used for these things.
Fair enough. Yeah. Thank you. The next question is colloidal silica the equivalent choice to using nanolimes in limestone? Is there a comparison that can be made between nanolimes and colloidal silica?
I think there is it compares quite to quite some extent. but the mechanisms of lime and sandstone, I think we have to consider them completely as being completely different and not really having to do very much with each other. You'll have to go through the research. I'm sorry.
Okay. Another question from Francesca. She's asking, was the delamination that was treated in 1997 observed to be stable when you examined 20 years later? What the delamination stable? And if yes, how did you assess the stability of the delamination? Did you do a knock test?
Yes, we did, and to some it was quite stable. There was some zones where we really were skeptical when doing it. And these zones were then showed to be not to be stable anymore. But and a couple of delaminations of five stones, from thousands of stones, had to be taken off in 2009. But all in all, these things were stable, and the decision for replacing the stones, over here, these over here, or these somewhat brighter stones over up here, was more of a aesthetic thing from a functional or view, or from question of the situation being stable. That they were stable when it comes to when the laminations had been taken off, and the edges were lined to some so that water could not intrude into these zones anymore. So these things was stable, but the replacement was actually done from out of a more aesthetic view.
And the treated delamination then 20 years later was left as such. I mean, you didn't have to do anything. The treatment done in 1997 was left as such.
Mainly, yes.
Okay.
As long as it didn't affect stones which were, there were stones which were in 1997 regarded as having to be replaced. So these were the endangering parts were just taken off.
Okay.
And in the end, this naturally led to a situation where these had to be replaced. Yes, but the points we had to retreat, these were mainly the cracks in these traceries, in these very dynamic parts.
Okay. Thank you. The next question is, do you have any experience with swelling inhibitors to prevent, reduce the deterioration of this kind of swelling? Swelling inhibitors, things that can reduce the swelling. Inhibitors that can reduce swelling.
Actually,
reduce this kind of.
I know there's a larger German company who tries to sell this very strongly and uses quite some effort in doing so. We actually don't use them. One thing is, over here we don't have glauconite. It won't have a positive effect on glauconite, on molasse sandstone, which is the main swelling thing on molasse sandstone. And the other thing is, but also on the sandstone we had at the Nusshaus we don't apply it. The thing is, one thing is, they don't continue. They don't on long term seem not to inhibit swelling. That's one thing, and the seem to. And the other thing is, they expand these clay minerals to a point where you usually don't go in a natural situation. So, in a natural rainy, even a fortnight of rain or so, you usually don't get them to this point where these materials actually bring it. And the other thing is, this is mainly a matter of setting up a project. You have to apply these materials in a way that they penetrate very deeply. And this means they are all solved in water, so this will extremely strongly wetten your facade, which will probably take months to dry. And this is something I can, you'd have to put up scaffolds a year more in order to apply these materials. Try to sell this to some owner.
Yeah. The next question is, do you have any reports or a documentation about the success or failure of swelling inhibitors treatments on any site? Is there any information?
There have been laboratory tests, mainly. We didn't apply it. Mainly because of the prolongation of the project, but at the first point. But the publications I know, they were all in German. I'm sorry.
Okay, but there's some work which has been done, is it? People have used it. Now, from your point of view, do you think the treatment was a failure or a success? The gist of those publications, was it a failure or there have been any success?
Here at Salem-Abbey or the anti-swelling?
No, the inhibitors, the success of using swelling inhibitors.
We didn't employ it in any applied in any project. So I haven't come across any objects which it has been applied. Actually, the heritage authorities over here, there are colleagues which work there, and they were always very skeptical about these materials. So they were hardly ever probably applied in our area. And yeah,
Okay.
maybe they were applied on some minor objects, but
I think,
mostly in those cases would lack documentation, etc. So it's very hard to really nail it down.
I understand. So thank you so much. Okay, there's one more question again, I think on the same. In regard to laboratory testing on swelling inhibitors used on molasses sandstone, you can find extensive literature from Timothy Wangler, George Scherer, and Jimenez Gonzalez. That's information shared by
Okay,
thank you
thank
so
you.
much. So there are some references there for everyone. It's been typed out. It's not a question. Thank you, Ninia Pratiko, for sharing this. So yeah, there you go. Some tests done. No other questions. So thank you so much. Thank you so much for a wonderful lecture. And I think there, as you said, there weren't many questions asked. I think people know about the problems faced, and I think it's a solution. It's an innovative solution that you guys came up with, and hopefully the result should be nice. Maybe
So,
time around.
I would just add, this is not it can't be a blueprint or so. It's just
Yes,
it's our first
definitely.
approach to this matter. So, and I thought it would be worth sharing or
Yes, I think definitely something to think about. And as problems arise, as we all know, it's then and there that one has to make decisions. And I think this was an innovative approach. Maybe it'll open doors to more people trying similar approaches and more data coming for the success of it on various.
hopefully sharing it.
Yeah, sharing it as well. Again, yes, brave of you. Okay, but thank you so much for.
Thank you for giving me the opportunity.
Yeah, thank you everyone for joining us. So that's bye bye from now. Bye.
Bye bye.
Bye. Thank you.